So I hope you tried problem 35 on your own. First thing I'm going to do is rewrite the root as a fractional exponent. So this is the natural log. On top we've got xy to the 1/3 and then over wz squared. Now because the x and y are connected by multiplication, that 1/3 power distributes to each of them. So I can say that's x to the 1/3, y to the 1/3 over wz squared. If I preferred to keep it together, I certainly could, although eventually I'm going to have to break apart that x and y. I think it's simplest just to distribute that exponent now if I want to. I will point out, I don't have the option of bringing that 1/3 down in front at this point because it doesn't apply to the whole thing. It only applies to the top of that fraction. Okay, now I have the natural log of this fraction, which is just four things connected with multiplication and division. The x part, the y part, the w part, and the z part. So I can break this up into a sum and difference. So this is the natural log of x to the 3rd plus the natural log of y to the 3rd. Those two are on top, they get a positive log. These two are on bottom, we'll subtract. Minus the natural log of w minus the natural log of z squared. Excellent. Now, these three terms I can simplify because I have a power in the argument. So I can use my power rule to bring those exponents down. So this will be 1/3 natural log of x plus 1/3 natural log of y minus natural log of w. Bring down that 2 minus 2 natural log of z. So that would be my expanded form for this one. All right. So now I want to try going in the other direction. If I have a sum and difference of a bunch of logs, can I combine them to get just a single log with coefficient 1? So write as a single log with coefficient 1. And I mentioned the last time we saw these directions that the coefficient 1 part, that requirement, was going to become clear once we had this next rule, which was our power rule. So let's suppose I had 2 log base 5 of x minus 3 log base 5 of y plus 1 plus 1/2 log base 5 of z. Okay. So now I'm adding and subtracting a bunch of logs. But if you think about what the rules were, our product rule and our difference rule, we had the log base b of xy was the log base b of x plus the log base b of y. All of that involves one copy of the log. Same thing for our quotient rule. We always had coefficients of 1 when we were applying these rules. So here I don't have coefficients of 1, so I need to use the power rule first to bring those coefficients up and turn them into exponents. Okay. So we'll have the log base 5 of x squared minus the log base 5 of y plus 1 cubed plus the log base 5 of z to the 1/2. Okay. Notice the 3 does not distribute over the addition, so this is just the quantity y plus 1 cubed. Now I can combine these. Once I've made my coefficients 1, now I can use my product and quotient rules. So I can say this is going to be the log base 5 of a single fraction. That has a positive log, so the x squared goes on top. That has a negative log, so the y plus 1 cubed goes on bottom. And I should really never have a negative exponent in my final answer. So I could have, in theory, brought up the negative 3 and been adding that. But y plus 1 to the negative 3 would be y plus 1 cubed on bottom. So generally speaking, I'll bring up the absolute value, but I'll keep the sign down there. Okay. plus the log base 5 of z to the 1/2. And I'm going to just rewrite that as the square root of z. X squared square root of z over y plus 1 cubed. I believe that's generally what the book does in giving the answers in the back of the book. Both of these are correct. Just read the directions carefully. If I specify to write fractional exponents as roots, I would be looking for this. If I don't specify, I would accept either version of the answer. Okay, excellent. So basically that power rule allows me to deal with coefficients that I might have in front of things. So let's let you try one of these. Again, I'm going to have you practice on one from the homework so that you're getting a jump start on that. This is question number 57. 3 times the natural log of x minus the natural log of x plus 3 minus the natural log of x minus 3. Okay. So, see if you can write that as a single log with coefficient 1. I'll just caution you, I think the first thing you want to do is just distribute that 3. Right now it's factored out. It's going to be a lot easier to work with if you distribute that as your very first step. So try this problem and we'll go over this one together at the beginning of the next video.